So today we are going to solve another paper of AS variant 1 for it's October-November 2025. Let's start with the first question. Okay. In the first question, they're asking what is essential to accurately represent all physical quantities. Okay. So for all physical quantities, we need units and the magnitude. So it is option C. Okay. In question 2, a steel rule can be read to the nearest millimeter. It is used to measure the length of a bar whose true length is this. Repeated measurement give the following readings. We have the number of readings are the readings accurate and precise to within the 1 millimeter. So what we have to keep in mind, what the precision is when we discuss about precision, its mean values close to each other. Okay, that will tell how much precise they are. And when we talk about accurate, it's mean values close to true value. So this is the true value that we have, and this is the data that we have. Okay, so when we talk about the accuracy, they're not close to the true value, as the true value is 895 and the values you have is 892, 891. So they are not close to that one, so they are not accurate. And when we talk about precision, yes, if you see them, they are close to each other. They're not spreaded, right? So it's option B that is correct. Moving forward to the third question, a stone is released from the rest and falls vertically to the ground. So rest mean U is equals to 0. The time taken to fall to the ground and the distance traveled are measured. The measurements are used to determine the acceleration of the free fall. Okay, so you have percentage uncertainty in time. This you can call percentage uncertainty. The percentage uncertainty in distance is also measured. Okay, so this is delta S. What is the percentage uncertainty in the calculated value of acceleration? Okay, you have to find A. Okay, so if we have to find A, what we can do, first thing, this is a free fall motion, constant acceleration, so you have to apply equation of motion. So when you look at the data, you have S, U, T, and A involved. So equation that will be applied is S is equals to UT plus half AT square. Okay, first you have to make A the subject. If you see the formula, this U is 0, so this thing will be 0. So S will be equals to 1 by 2 AT square, and A will be equals to 2S divided by T square. Okay, so our A uncertainty depends on S and T square. If you remember the rule for the uncertainties, when the values are multiplied or divided, the fractional or percentage uncertainties will be added. And there is also a power factor on them. So power factor rule will also be applied. So you can say percentage, let me write percentage uncertainty of A will be equals to percentage uncertainty of S plus, and there will come a 2. Why? Because there is a square on the T, multiply by percentage uncertainty of T. So this will be percentage uncertainty of S is 0.6 plus 2 multiply by 0.05. So this thing will give you 0.7%. It's option B that is correct. Moving forward to the next question, question 4. An object fall from the rest towards the ground, so U is given 0. A resistance is negligible, its mean acceleration should be constant. Which graph shows the variation of the momentum P of the object with time t? Okay, if you remember the formula for the momentum, it is P is equals to mv. Acha, m will remain constant, so you can say p is proportional to v. So the velocity time graph or the momentum time graph will be same. So as we know, when the acceleration is constant, the velocity time graph is constant. It should be a diagonal straight line. So momentum time graph will also follow the same pattern. So it will be option C that is correct. In question 5, a projectile is fired at an angle of 45. So you have theta upward from the horizontal. A resistance is negligible. Its mean acceleration can be taken as g, that is constant. Which row describe the horizontal motion and vertical motion of the projectile motion immediately after, before it reaches the ground again? Okay, so if you remember the projectile motion topic, if something is launched at some angle, the angle is theta. What you need to keep in mind, there is only acceleration will only be acting vertically, and that will be constant. It will be equals to g. Horizontally there will be no acceleration, so you can say horizontal velocity remain constant. Why? Because there is no force acting in the horizontal direction, right? Gravity only act in the vertical direction. So this will be the option A that is correct. Horizontally, velocity will be constant and vertically, acceleration will be constant. Moving forward, question 6, an aircraft on a runway accelerate uniformly from the rest and take off at a speed of this. So you have this u0, you have the v. The acceleration of the aircraft is given, you have a as well, and the aircraft uses 74% of the length of the runway. Okay, what is the length of the runway? 74% he has used. Okay, so let's find, you have to find s. Let's suppose the length of the runway, let's call length of the runway is equals to L. Okay, first we will find the distance covered by the aeroplane. So we are going to find s first of all. So we have, let's look at the data. We have u, we have v, we have a, and we have to find s. So we have to pick the equation of motion that does not include the time. So we can use the equation that v square is equals to u square plus 2as. So s can be written as v square minus u square divided by 2a. Okay, just you have to put the values. V is 58, u is 0, and 2 and a is 4.2. That will give you 400.47 meters. Okay, this is the distance. Okay, this is the distance that is covered by the aeroplane, but we have to find the length of the runway, and this s is basically 74% of the L. What you can say, what we know from the equation, that s is equals to 74% of length of runway, we call it L. So what I can say, s is equals to 400 is equals to 74% of L. So L will be equals to, okay, let's do it like this. 74% when changed into fraction, 74 divided by 100 is 0.74 L. So L will be equals to 400 divided by 0.74. So that thing will give you 541. I guess that is nearly 540 when you round it off. So it's option B that is correct. Moving forward, question C. How can the acceleration of an object be determined? Okay, to find the acceleration in option A, they're telling from the area under the displacement time graph, no. From the area of velocity time graph, no. From the gradient of, from the, yeah, it's option D that is correct. From the gradient of velocity time graph, you can find the acceleration. Question 8. The acceleration of free fall on the earth is different to the acceleration of free fall on the moon. How do the mass and weight of the object on earth compare to the mass and weight? This is a very basic question. Mass will not change on any planet, but the weight will depend on the gravitational field strength. So it's option C that is correct. Moving forward, question 9. A sphere move vertically downward at a terminal constant velocity in a liquid. Which statement about the magnitude of the upthrust acting on the sphere is correct? Okay, so we know upthrust force can be given by rho g v, right? So in option A, it is proportional to the acceleration of the free fall. Yes, you can say force is proportional to the acceleration of free fall. It's option A that is correct. Okay. B is not correct. It is equals to the weight of the sphere. No, it is not equals to the weight of the sphere because the forces are balanced, but we know the downward force will be the weight, and upward there will be two forces. One force is the upthrust that is acting on it, plus there will be a drag force as well that will be acting on it. Okay, so B is not the right option. A is the option. In question 10, an object of mass 2 kg is traveling at a speed of 2 meter per second on a horizontal frictionless surface. Okay, so you have the speed. The object collide head on with a stationary object of mass 1 kg. The two objects stick together on impact. How much kinetic energy is lost in the impact? Okay, so you have to find the kinetic energies, difference in kinetic energy, right? So what you have to do, the change in kinetic energy will be equals to kinetic energy total initially minus kinetic energy total finally. Okay, you have to subtract them. So to find kinetic energy you need velocity. Initially if you see, there is only this object that is moving. This kinetic energy is 0. So for kinetic energy I can write 1 by 2. Mass of the first object is 2.0 and velocity is 3 square, so this will be 9 joules. Kinetic energy final, you need 1 by 2. They are moving together, so their combined mass will be used 2.0 plus 1.0 multiply by velocity square, and this velocity we don't know. So to find this velocity we can apply conservation of momentum. So total momentum initially should be equals to total momentum finally. Initial momentum is 2.0 into 3.0. The second object was at rest, so its momentum is 0. Final momentum will be the both masses are moving together, so it will be 2.0 plus 1.0 multiplied by v. So v can be written as this 2 into 3 is 6 and 2, sorry, this is 6 and 2 in plus 1 is 3, 2 meter per second. So this v is 2. So I can put this value here. This is 2 square. So this thing will give me 6 joules, right? So the change in kinetic energy when you find, it will be initial is 9, final is 6, it will give you 3 joules. Okay. Let's move forward to the question 11. A moving object X collide with a stationary object Y. The object separate after the collision. The collision is perfectly elastic and there is no external force. Which word equation is not correct? Okay. Okay, what the A is, during the collision, force acting on the object X plus force acting on the object Y is equals to 0. Yes. How you can write this thing, that F of X will be equals to, when this thing go on the right side, minus F of Y. This is as per the third equation of motion, Newton third law, that the action and reaction forces are equal but opposite in direction. So that is true. That is not false. Second is relative speed of approach of x and y plus relative speed of separation of x and y equals to 0. No, that is not correct. Because when you shift this thing there, it will come a negative sign. And we know the relative speed of approach should be equals to relative speed of separation, not minus, not with a minus sign. Okay, so this is wrong. Okay. If there is a negative sign, it will be correct. But there is no negative sign, so this is wrong. In question 12, the diagram shows a stationary sphere that is just fully submerged. In a liquid, the radius of the sphere is r and the density of the sphere is rho, the acceleration of the g. Okay. The air exert a pressure PA. What is the pressure at the lowest point on the sphere? Okay. So let's suppose if it is there, the pressure at this point, that is the pressure of liquid, that is PA. And when you move downward, the pressure of liquid will be added. So you have to tell total pressure, right? So we know total pressure is pressure of air plus pressure of liquid. Pressure of air is PA, pressure of liquid is rho G H. Okay. Um, but we don't have in this form any relation, so we have to convert this thing. How we can convert? Okay. We don't have the height in any of the relations, so we have to change the height. What we can do, we know this is given in the form of 2r and this thing. Okay, so what looks correct to me is C. But how we can make this rho gh equals to 2r rho g? If you see closely, this is 2r. What is the r? R is the radius. What is the height or the depth? This is the depth, right? This is the h. And if you see, this is the center of the sphere. Let's suppose this thing will be r and this thing will be another r. So if you add both of them, this r plus r is equals to h, and that is, sorry, that is 2r is equals to h. So you can perfectly write down this thing as equals to this. So it's option C that is correct. Okay. Moving forward, question 13. A uniform rod is attached by a hinge at one point, at one end to the wall. The other end of the rod is supported by a wire. Okay, so that they are in equilibrium. Which arrows show the direction of force on the rod from the hinge? What you have to keep in mind, if the three objects, if the three forces, four forces or five forces are in equilibrium, they should cancel each other. So when you apply head to tail rule, what is the condition? Head of last vector should be at tail of first. Okay, one thing. And where should be its tail? Tail of last vector should be at head of second last. Okay, that you have to see. For equilibrium, okay, keep in mind for equilibrium, this is the condition. Okay, so let's work it out. What forces we have? One force we have the rod is hinged, the other end supported by the end, equilibrium. Okay, one force is this force, that is the weight, and the other force you can say that is the tension. Okay, so if I draw these forces, let's suppose this is the weight and the tension is, let me draw it here. When you apply the head to tail rule on it, the tail of the second should be the head of the first. It will be somehow like this. Okay, this is the tension. The resultant should be, its tail should be on the head of the second last and head should be on the tail of the last. So this is the third vector. Third vector should be like this. Then you can say where the head of the last is, the tail of the first is starting from there, their resultant vector will be equal to 0 in that condition. So if you see, this is not the option, this is not the option, this is not the, this is the option, that is option D. Okay. Moving forward, question 14. A couple is applied to a tap. What is the torque of the couple? Okay, for the couple, what you have to do, you have to multiply this force. You just have to multiply one time with the force, with the distance between the two forces. So force is F and distance between them is 2D. It can be written as 2FD, option C. Okay. Moving forward, question 16. A uniform beam rests on two supports, X and Y, as shown in the diagram. The beam has a length of 20 meter and the weight of 200 newtons. A man of weight 700. Okay, so we have the data. For the beam of the length, we have weight. For the person, we have 7, and its distance is 6. The beam is in equilibrium. Okay, what is the contact force of support X on the beam? So contact force will be like this, that you have to find. Okay. And what we know, how many forces are acting there? One force acting on X, the other contact force will be acting on Y. Let's call it Fx, call it Fy. One thing we know for sure, that if I write down sum of upward forces will be equals to sum of downward forces. Upward forces are Fx plus Fy. Downward forces are 700 plus 200. So this can be written as 900 Fx plus Fy. Or we have to find Fx, so Fx is 900 minus Fy. So I don't know what the Fy is. Okay, another thing, this person is not standing at the middle. If this person is standing at the middle, its weight will be equally divided here and here. And the weight of the beam will also be equally divided here and here. Okay, but it's not standing at the middle. So we have to find Fy. So to find Fy, what I can do, I can apply for Fy, applying principle of movement, sorry, principle of movement. Okay, now it's my choice. I can choose pivot point X or pivot point Y. Okay, but I will choose intentionally the pivot as a X because I need the force Fy. If you choose the pivot at a point Y, you can't find the force Fy. Okay, so this is intentional. We are choosing the pivot at X. Now I have to write down the moments. If the pivot at X, how many forces are acting upwards? If this will apply a anti-clockwise movement, this force will apply a clockwise movement, and this will also apply a clockwise movement. Okay, so anti-clockwise movement, let's write it down. This will be Fy will be equals to, you have to take the distance from the force till the pivot point. This is the total length of the beam, and that is 20. Okay, and for clockwise movements, let's call this 1, let's call this 2. Clockwise 1 plus clockwise 2. Clockwise 1 is 200. Multiply with the distance. It is exactly acting at the center because the beam is uniform. So it will be 20, half of the 20 is 10 plus the second is 700 Newton force, and its distance from here is 6. Okay. So clockwise movement is equals to anti-clockwise movement. So this will give us Fy into 20 is equals to 200 into 10 plus 700 into 6. Okay. So Fy can be written as 200 into 10 plus 700 into 6 divided by 20. Let's do the calculation. And when you calculate it, it will give you 310 Newton. Okay, now what I can do, I can use this equation. I can put this value here. So what I can do, so Fx is equals to 900 minus 310. So this thing will give me 590. It's option C that is correct. Okay. Let's move forward. Question 16. The diagram shows a block P of mass m connected by a string over a frictionless pulley to a block Q of mass m. Block P move up the slope with a constant velocity. Okay, P is moving up with a constant velocity, so Q will move down with a constant velocity. The slope is at angle theta to the horizontal. The acceleration of free fall is g. The resistive force on the blocks are negligible. Which expression give the energy transfer per unit time? So energy transfer per unit time is basically what we call this thing as it is power. Okay. We have to find the expression which expression is the energy transferred per unit time. Okay. We have three expressions. What we have to look at first thing, this is mass small m because expression are in term of small and capital M, and this is given in the question. This is capital M. We know this M is losing GPE. So its loss of GPE, gravitational potential energy, is basically is gain of kinetic energy for M and for capital M as well, for P and Q both. Okay. So what I can do, I can write it as power is equals to mgh divided by T. That is the power delivered. So this can be written as mg h over T. So h over T is basically this thing is representing a distance over time that is covering that can be written as mgv. So this we know this equation one is correct. Okay. Okay. For second, what we can choose, if you see, the second we have to look for this thing. So its velocity is v and it is moving in that direction. This velocity is, if I make an angle, this is the v and this v is making an angle theta with it. We need a velocity in the change in velocity in which direction, in this direction, sorry, in this direction. Okay, because it is gaining the kinetic energy because of the change in potential energy, and the change in potential energy, how we can write it as, I can write as for the for this P, for P box, I can write mgh, that is the change in potential energy because it's gaining height divided by time. It can be written as mg, and this is h by t. Okay, so h is the vertical component of the velocity. So sorry, vertical component of the displacement, you can say, height it's covering. So this will give you the vertical component of velocity as well. So v sine theta you can write this thing as. Okay, so this thing is also true, but this is not true, the option C. This is not making sense. Okay, you can't drive this thing, so it's option A that is correct. For question 17, a toy car travel around a vertical loop. The toy car is released from the rest. It's moving from here at a height of 58 centimeter above the bottom of the vertical loop. The car is at height of 32 centimeter when it at the top of the vertical loop. Assume that the no resistance resistive force acts on the car. What is the speed of the car at the top of the loop? Okay. So at this point, this thing will have GPE, that is mgh. Okay, we have to find at this point, when this thing is at this point, it's lose some of the GPE and it will have some gain some kinetic energy. Okay, So the amount of loss in the GPE will be equals to gain in the kinetic energy, you can say. So I can say change in GPE, gravitational potential energy, will be equals to gain of kinetic energy, because initially it was zero, or you can say change of kinetic energy as well. So change in GP is mg delta h, and this is half mv square, and m, you know, it is okay. M you don't need to know, m will be cancel out. We have to find v, so v can be written as v square will be equals to 2g delta h, and you have to take the square root. So v will be equals to under root 2 into 9.8 into change in height, as it was at 58 and it is going at 32. So this will give you 2.3. It is option B that is correct. Moving forward, question 18. In question 18, the total energy supplied to an electric motor is E. Energy Q is wasted and the remaining energy does useful work. What is the efficiency of this thing? Okay. So what we have to look at, this is the total energy, and this is the wasted. So useful energy will be equals to E minus Q. And we know efficiency is useful energy divided by total energy. Useful energy is E minus Q. Total is E, but we don't have anything in that form. What we can do, we can write as E over E minus Q over E. They will cancel out. It will give you 1 minus Q over E. It's option C that is correct. In question 19, an object traveled between 2 points. The change in the gravitational potential energy is delta E. P of the object is given by this equation, where m is the mass, delta h is the change in the height, g is the acceleration. What is the necessary condition or order for the above equation to be valid? Okay, so to be valid, the object must have a constant acceleration of 9.81. No, this is not mandatory. This can be applied to any scenario. Okay, even if it's on other planet where 9.81 is not the acceleration, it can be applied. B, the object must be traveling in a uniform gravitational field. Yes, because this g is taken as constant, it should not change. If it is changing, then you have to consider different scenarios. Okay, in question 20, a cylindrical steel rod with a negligible weight has a diameter of 1.5 centimeter and a length of 5.2 centimeter. The rod is firmly attached at the top end, and this is the scenario that is given. The rod is firmly attached to a machine at the other end, and that applies a constant force of 363 newtons. So you have the force, you have the initial length, you have the initial diameter. Okay. This causes the rod to extend to a length of 7.4, and minimum diameter is now this. The force is same. What is the maximum stress acting on the steel rod when the length is 7.4? Okay. Maximum stress. Okay, so if we write down the relation for the stress is force over area. We don't have the area, we have the diameter. We know area is equals to pi d squared divided by 4. So you can write as force divided by pi d squared divided by 4. So from there it is clear stress is inversely proportional to diameter square. So what we need maximum stress. So for max stress, we need minimum area. Sorry, minimum diameter. Okay. So Which diameter is minimum? This one is minimum, obviously 0.06. Okay, so what we have to find, we have to stress at that value. So let's do it. So stress is, we will use this relation. Stress is equals to force, this divided by pi d squared divided. It can be written as 4f divided by pi d squared. So 4 into f is 363. Pi will remain there, and this will be 0.006. Okay, because we have to change into the meters. 0.006, and there is a square on it. So when you solve this value, it will give you 1.310 raised to power 7 Pascal. It is option D that is correct. Okay. Moving forward, the graph shows the variation in extension with a force for a sample of rubber. The top line shows the extension of, okay, so there it is moving. The top line is showing the extension. The bottom line shows the variation in extension. The force is removed, so it is moving back in that direction. What is represented by the area between the two lines? So this area they are asking. This is the loss of energy. Loss of energy. Okay. This total area that is under the upper line, this total is work done in extension. This lower line is, this area is showing you the work done when it come back to the original shape, and the difference of both of them will show you the loss of the energy. So it is option B that is correct. Okay, so two identical springs have the same spring constant K. The springs are connected in parallel. The length of the unstretched spring is X. The force is F is applied, and then the length of the spring is now Y. Okay, so originally it was X. Finally, the length is Y. The force is F. Both springs are deformed in the limit of proportionality. It's mean we can apply the Hooke's law, which expression give the elastic potential energy. So elastic potential energy, we know it is equals to 1 by 2 F into X. This X is basically change in length, right? And in our scenario, this thing, the change in length is Y minus X, because it is finally Y, initially it was X. Okay, so let's do for both of them. You have, we have two springs, right? So let's call this one, let's call this two. So elastic energy total will be elastic energy of first plus elastic energy of second. Okay, the first of it will have 1 by 2. The forces will be same, the same. The forces acting on both of them is same, basically it's given, right? It's F force that is applied to the spring combination. So it will be, no, the force is F that is applied on this. So this force is equally divided on them. So for the spring 1, the force that this will have, this will have F by 2, and this will also have force F by 2. It will be equally divided. So, and this force will be F by 2. So this will be F by 2, and its extension is Y minus X. Okay. And for the second, it will also be 1 by 2. Force will be F by 2. Extension is same because both are attached with each other. So it will be like this. You can write it as 1 by 4 F into Y minus X plus 1 by 4 Y minus X. Okay. So okay, so we don't have to find the total. We have to find energy stored in one of the springs. So this is the energy stored in one of the spring. Okay, For both of them, this the energy. So it's option this 1 by 4 Fy minus x. That is the correct option. Okay, that will be the energy stored in the springs. Okay, so let's move forward to the question 23. Which expression gives the formula for the spring constant? We know F is equals to kx, so k is equals to F over x. It's option C, that is correct. Moving forward, a transverse progressive wave travel along a string. The graph shows the variation with the distance and the distance of the displacement of the string at a time t is equal to 0, which graph represents the variation with time. Okay, so this graph is between the displacement and the distance, whereas these graphs are between velocity and the time. You have to tell about the variation of the velocity for the point P. Point P is at this point. If you see, if you trace the wave, let's suppose this is the wave. So as the wave move forward, you see the P will be after some time, the P will be somehow at this point. So P will move down, and this side, the displacement is negative. So this will have negative displacement. So negative displacement mean it will have negative velocity. So, and secondly, it should be a sinusoidal graph. Okay, it should follow a sine wave. So you have to choose between C and D, and the one that is starting with the negative velocity is D. Okay. Question 25, which statement about electromagnetic wave is correct? Very easy question. It's option the wave of electromagnet, a wave of wavelength. This is invisible. Yeah, it is not in the range of visible light. Okay, so you have to memorize in electromagnetic spectrum the range of all the spectrums like IR, UV, X-rays, gamma rays, and visible light. Okay. For 26, for a progressive transversal wave, would describe the term diffraction. Okay, what the diffraction is? Diffraction is the spreading of waves when it passes through a gap. Okay, so it's option B. 27, an aircraft flies at a velocity of Vs directly away from the stationary observer. The aircraft emits a sound of constant frequency. The speed of sound in the air is V. The frequency of the sound here by the observer is 500 hertz. The speed of the aircraft is increased. So it flies away from the observer at a greater velocity. The observer now hear a sound of frequency 250, which expression give the new velocity of the aircraft. Okay, so this is, by the way, from the topic Doppler effect. Basic relation we have is observed frequency is equals to frequency of source multiplied by the speed of sound divided by V plus minus Vs. Okay, so initially what we have, let's work out the initial conditions. The observed, this is F naught initially, so we can write 500 is equals to the frequency of source was not given, it is Fs. The velocity was V of the sound. Okay, it will remain same. V plus the speed, the lower speed was also not given, it is Vs. So this is the expression initially. Okay, so after increasing velocity, what we can write as, now the observed frequency is 250. So I will write, I'm again going to apply the, going to put the values in the given formula is equals to Fs. Okay, this is Fs will remain same, speed of sound will remain same, but this velocity is now changed. This is the V new. Okay, so we have to find the expression. What I can do now, I have the two different expression, one is this one is this one. To find the unknown or to find the expression, I can divide them. So when I divide them, Let's call this 1, call this 2. 1 divided by equation 2. 500 divided by 250 is equals to FSV over, let me write it down like FSV over V plus Vs divided by Fs into V plus V new. Okay, so in this thing, they are cancelled out. This will be 2 and this will go on the numerator, so it will be 2 is equals to V plus V new divided by V plus Vs. Okay, so we have to find expression for the new velocity. What I can do, this will go and multiply it there. It will be 2V plus 2Vs is equals to V plus V new. We need V new, so this will go on the left side and will be minus. So V new is 2V plus 2Vs minus V. So this will give us 2V minus V is V plus 2Vs is equals to V new. Let's look if we have any options like this. Yes, C is the right option. Okay. Moving forward, question 28. What may be observed with a light wave but not with a sound wave? Okay. What we can observe? We can observe the polarization. Why? Because light wave is transversal wave. Transversal wave can only be polarized. Longitudinal wave will not be polarized. Okay. Question 29. A wire is fixed at both ends and is vibrated by a source of frequency F. A stationary wave is formed on the wire with a total of two antinodes. Okay, it is fixed from the both ends and two antinodes are formed. The frequency of the sound is increased to 3F and a new stationary wave is formed. What is the total number of antinodes formed? Okay, so it is the case when both the ends are fixed. So when both ends are fixed, there will be nodes on both the ends, right? So in that type of scenario, if you remember the formulas, increasing the frequency will increase the number of nodes. So if you are increasing, if frequency was F, nodes were N. If frequency is 3F, the nodes will be 3N. So initially the nodes are 2. So now they will be 3 into 2, they will be 6. Okay, it's option 6. C. Question 30. A parallel beam of red light of wavelength is given, that is the lambda incident or diffraction grating, that has, this is n you have. What is the total number of intensity maxima from the grating? So maxima mean theta, you will take 90. So formula we have n lambda is equals to d sine theta. So when you take theta 90, so this thing will goes to 1. So n lambda is equals to d. You have to find n. So n is d by lambda. Okay, what the n d is 1 by n. And what the n is, we have to find n, we have to convert into the meters. There are 400 lines per millimeter. Okay, if there are 400 lines per millimeter, then there will be, 1 milli is 10 power minus 3. So meter is, to convert into meter, you have to multiply with 1000 if you have to convert this thing into the meter. So if there are 400 lines in 1 millimeter, then there will be 400,000 lines in 1 meter. Okay, simply. So this will be 1 over 400,000. So putting the value here of d is 1 over 400,000, and lambda is, we have 700 nano is power minus 9. Solving this, we will get 3.57. Okay, now you have to round this thing to the lower decimal because the pattern will not be in the fraction, right? They should be in the integer number. So it will be equals to, you will be round off to 3. So there are order is 3. So how many total number of diffraction grating will be there, you have to find. Okay, so if let's suppose, if you remember, diffraction gratings are made in that pattern. This is called the zeroth order. This maxima is 1, this is 2, this is 3. If there are 3 maximas above, then there will be 3 below as well. 1, 2, 3. So how many total maximas are there? 1, 2, 3, 4, 5, 6, 7. So 7 maximas will be there. So it's option B that is correct in that case. Question 31. Two light sources are used to produce an interference pattern. Interference fringes appear when the two sources emit waves that are coherent. What is meant by coherent? So, coherent is basically the two waves should be in the constant phase. They are called coherent. Okay. Which component has the IV graph shown? This is for the filament length simply. Question 33. They have given you a diagram and you have to tell what is the circuit diagram for this thing. So if we tally this thing, we have the power supply. Okay, the power supply is here for this case, and with power supply, this is the variable resistor or the potentiometer that is attached. Okay, so okay, this is correct. This one seems correct, and this one seems correct. They are wrong because ammeter is not attached directly with the power supply. Okay, so C and D are not the options. Now look between B and A. So ammeter is attached with one end is attached with the variable resistor and second is with LDR. One end is with the variable resistor and second with LDR. Yes, this is the thermistor. This is not this. So A is the right option. Okay, we have the LDR, not the thermistor. In question 34, a copper wire of length 2 meter has a circular cross section. There is a constant current in the wire when it is connected to a mobile phone in order to charge the battery. A wire has a fault. A 1 meter length of wire has a half the diameter and the of the other 1 meter. Okay, so the total is 2 meter. Half of the length have half the diameter than the other one. The power dissipated in the thicker length of the wire is P. What is the power dissipated in the thinner length of the wire? Okay, so let's make the scenario first. You have a total, let's suppose this is the wire, and then there is a bigger area of the wire. They are like this. So this, let's suppose, is D, this is D by 2. This is L, 1 meter. This is also 1 meter. Because and as they are in line, there will be a same amount of current passing through both of them. Okay, so we have to find power dissipation. We know power is I square R. What we have, the power dissipation in the thicker wire. Thicker wire have a diameter D. So current is same, we have to deal with the resistance. So what the resistance will be, resistance we know R is equals to rho L over A. Material is same, length is same, so we are concerned with the area. We know area is pi d squared divided by 4. So it can be written as 4 rho L over pi d squared. Okay, so this is the resistance. So if I put this thing here, I will get, let's write it here, P is equals to 4 rho L, and there is I square over pi d square. Okay, so this is the expression for the power when diameter is D. Okay, so when we take, we have to find for the thinner wire. So let's do it when D is, diameter is D by 2, things will change. Let's call it P of power of thinner wire Current will be same. I'm going to copy this relation for it. Okay, current is same, 4 is constant, density of the material is same, resistivity base is same, length is same, pi is the constant, diameter will be d over 2 instead of d. Okay, I have just replaced this thing with d over 2. There will come a square. It will be a 2 square is 4, and this 4 will come above. This will be 4 multiplied by the whole thing, pi d square. And if you see, this thing is basically equals to p. So I can write as p of a thinner wire is 4 times of the p. Okay, so it's option D that is correct. Moving forward, a wire carries a current of 5.6 ampere. What is the number of conduction electron that pass the point? Okay, so we have to use a basic relation of the current. I is equals to q over t, and total charge is ne over t. You have to find n. So n can be written as I into t divided by e. I is 5.6, time is 20, and e is constant charge on electron 10 power minus 19. Solving this, you will get 7 into 10 raised to power 20. It's option D. Question 36. Four resistors of the resistance R, 2R, 3R, 4R are connected. The battery is shown. And what they're asking, the voltmeter showing 2 watts. So there is 2 watts. What is the electromotive force that you have to tell? Okay. If you see, if we apply Kirchhoff's second law on this thing, they all, this 3R, this 2R, this 1R, they are in series. So they resist, their voltages depend on the ratio of the resistance. If 2R have a voltage 2V, this will have 3V, this will have 1V. So total EMF should be equals to total voltage in a loop. That will give me 6V. It's option C. Question 37. The circuit diagram shows a battery with an internal resistance R, two resistances, a switch, and a voltmeter. The switch is now closed. Okay, this switch is closed, and you have to tell what will happen to the current in the battery and the reading on the voltmeter. Okay, so first we need to understand how they work. So the current from the battery, this I, this I is total current. Okay, when you are closing this switch, we know in parallel total R decrease, so total I increase. This is the first thing. So we have to choose between A and B. Okay. Now let's look at the reading on this voltmeter. This voltmeter is actually reading output of this battery, of this thing. What is the output of this thing? This thing is giving a EMF E, and there is a voltage IR. So the output is basically the voltmeter reading is E minus IR. Okay. Okay. As you see, this I is decreasing. Sorry, this I is not decreasing. This is increasing. We just have written. So this I is increasing. So if I increase this whole term E minus IR, this whole term decrease. So voltage reading on the voltmeter also decrease. So it's option A that is correct. Moving forward, question 38. What are the correct equations for the beta decay? It's very simple. It's option D. Proton turns into a neutron plus positron plus electron neutrino. Question 39. A nucleus of plutonium is polonium is decayed by a alpha particle to become a nucleus of lead. Let's do it step by step. We have PO, that is 214. We have to find number of neutrons. Okay, so it is 84. It is decaying alpha, alpha is 4 2, it will become lead. Okay, I don't need to know the symbol for it. If there are 14, 4 go there, so there will be 210, and there will be 83. Okay, sorry, 81, 82, sorry, 84 minus 84 minus 2 will give you 82. Now we have lead have lead is 210 and 82. Now this lead is decayed by emitting beta and will become bismuth. So lead is emitting beta, beta is 0 minus 1, and it will become, so 210 minus 0 is 210, the mass 82 plus 1, because whenever beta emission you have minus beta emission you have to plus 1, it will be 83. Okay, next statement they are telling you, which then decayed by a beta negative particle to become X. Now this bismuth, this is 210 83. This is decaying by beta negative again, and it will give you the X. So 210 minus 0 is 210, and 83 plus 1 is 84. So you have to tell number of neutrons in the X. So to find number of neutron, you have to subtract them. 210 minus 84, 126. It's option A that is correct. Moving forward, which combination of three quarks has no overall charge? It is option D. You have to memorize the charges of the quarks.